Hi students, good evening to all of you. Today we are going to discuss about Vesper theory belongs to chemical bonding unit. From this theory, generally we are expecting one question for different competitive examinations. Frequently we are getting one question from this topic for different examinations like JEE, NEET, KSET, MSET, TSET and PGSET. Right. Okay, now let's start. The name suggests that Vesper theory, the name suggests that valence cell electron pair repulsion theory. This theory is proposed for what purpose? To explain geometrical shape and bond angle of a covalent molecules. Right. According to this theory, the geometry of a molecule and bond angle of a covalent molecule is decided by valence shell electron pairs undergoes repulsions. That means the repulsions between the electron pairs present in the valence shell of a central atom decides the geometry and bond angle of a molecule. Right. That means if the molecule having the valence shell electron pairs of a central atom are of two types. The electron pairs present in the valence shell of central atom are of two types. There are two types of electron pairs present in the valence shell of an atom. Those valence shell electrons which are participating in bond formation are called bond pairs of electrons, and those valence shell electrons which are not participating in bond formation are called lone pairs of electrons. Both lone pairs and bond pairs of electrons will decide the geometry and bond angle of a covalent molecule. Generally, the bond pairs of electrons are attracted by nucleus of both central atom and bonded atom. Hence, they occupy less space around the central atom. But lone pairs of electrons occupy more space because these are attracted by only nucleus of central atom. They occupy more space around the central atom. Right? Now, if the molecule having only bond pairs of electrons, the molecule having only bond pairs of electrons, the molecule having only bond pairs of electrons, the molecule have regular geometry. The molecule having regular geometry, normal geometry, there is no any deviation in the geometrical shape of the molecule. But if the molecule having lone pairs of electrons along with bond pairs, then that deviates the geometry of the molecule. That deviates the geometry of covalent molecule. That means here the geometry of the molecule is decided by both bond pairs and lone pairs. But the shape of a covalent molecule is decided by only bond pairs of electrons. Only bond pairs of electrons only. The shape of the covalent molecule is decided by only bond pairs of electrons. But geometrical shape, geometry is decided, that is arrangement of electron pairs. Geometry is different, shape of the molecule is different, my dear students. Geometry means arrangement of electrons, all the valence electrons around the molecule. Right. Now, repulsions are taking place, right? Between what? Between you and me? No. Between lone pair, bond pair, and bond pair. That is the order of repulsions. The order of repulsions between the electron pairs is lone pair of electrons causes greater repulsions than lone pair bond pairs of electrons. which causes more repulsion than bond pair of electrons. Right. Then if a molecule having any double bond, there is multiple bonds, maybe double bond and triple bond. In case of multiple bonds are present, in a covalent molecule, then these bonds also causes repulsions. So in that case, there is a triple bond causes greater repulsion than double bond, which causes greater repulsion than single bond. Here in the case of triple bond, pi bonds are 2 are present, 1 sigma bond. In case of double bond, 1 pi bond, 1 sigma bond. And in case of single bond, only sigma bonds are present, right? So that means the order of repulsions of a pi bond repulsions are more greater than pi bond sigma bond, here pi bond and sigma bond, here pi bond, right? So pi bond repulsions are greater than pi bond sigma bond, and which is greater than sigma bond, right? So generally, my dear students, in case of multiple bonds, according to Vesper theory, multiple bonds are counted as a single super pair only, single bond only. Multiple bonds are considered as single bond, single super pair. Okay, got it, my dear students. These are the important postulates of Vesper theory, my dear students. Okay, is it clear concept? By applying these postulates, now we are going to discuss about different different covalent molecules, their geometry and bond angles. Right? So just fastly take a screenshot, my dear students. I want to explain some examples. Right? Do it fast. Copy. Can I erase it now? Fine. Right. Now we are going to discuss about applications of Vesper theory. Right. I will explain the 3 examples. It is very easy to get the concept. For example, take methane molecule. In methane molecule, central atom is carbon. So it having how many valence electrons? 4. 1, 2, 3, 4. And what is the bonded atom? Hydrogen. How many hydrogens are there? 4. Each one can contribute 1 electron. Right? Now around the central atom, total number of electron pairs. Total number of electron pairs. How many? 1, 2, 3, 4. 4 electron pairs are present. Among that, it forms one covalent bond. This pair forms one covalent bond. This pair forms one covalent bond. This pair also forms one covalent bond. So that's why totally this is a bond pair, bond pair, bond pair, bond pair. So how many bond pairs of electrons are there? 4 bond pairs. That is number of bond pairs of electrons. How many? 4. Right. Then is how many number of lone pairs of electrons? 0. There is no lone pairs of electrons. All the electron pairs present around the central atom are participating in bond formation. All are bond pairs only. That's why the geometry of the molecule is tetrahedral. Right. So how many bond pairs? 4. 4 you can call this tetra. Tetra means 4. So 4 are there. 4 bond pairs, tetrahedral. Next, what is the shape of the molecule? The shape of the molecule is also regular geometry because there is no lone pair, right? So that's why the shape of the molecule is also tetrahedral shape of the molecule, right? Then what is the bond angle? Bond angle of the molecule. Bond angle of the molecule is 109 degrees 28 minutes, my dear students. 109 degrees 28 minutes, right? Yeah, this is about methane molecule. Next we go for another example, that is ammonium molecule, NH3. Here central atom is nitrogen. Nitrogen belongs to 15th group, having how many valence electrons? 5. 1, 2, 3, 4, 5. How many hydrogens are approaching bonded atoms? 3. That is 1, 2, 3 hydrogens. Each hydrogen can contribute one electron. Now, around the central atom nitrogen, how many electron pairs are there here? Around the central atom nitrogen, how many electron pairs are there? 1, 2, 3, 4 pairs are there, right? So, how many electron pairs? 4 pairs of electrons are present, right? So, total number of electron pairs around the central atom is 4 pairs. 4 pairs are there. Then, among this pair involved in bond, this pair involved in bond, this pair also involved in bond. But this pair is not participating in bond formation. This is called lone pair of electron or non-bonded electron pair or unshaded electron pair. And these 3 are bond pairs of electrons. Now, how many bond pairs of electrons are there? 3. And how many lone pairs of electrons are there? 1. This one. 1 lone pair of electron is there. Right. Okay. Then because of that, so totally how many electron pairs are surrounded the nitrogen atom? 4. That's why the geometry of the molecule is tetrahedral, my dear students. The geometry of the molecule is tetrahedral. 4 are there totally. 4 means tetrahedral. But this lone pair causes repulsions on the bond pair. It causes repulsions on the bond pair. It causes repulsions onto the bond pairs of electrons. Because of that, the tetrahedral geometry changes to pyramidal or trigonal pyramidal. 1, 2, 3 are there, right? Bond pairs how many? 3. What I told previously, the shape of the molecule is decided by only bond pairs. So bond pairs how many? 3. That's why it is a trigonal pyramidal geometry. Trigonal pyramidal geometry. And what is the bond angle? As you know, if the regular geometry is there, regular bond angle, because only bond pairs, but here lone pairs causes repulsions. That's why the tetrahedral bond angle, that is 110 degrees 28 minutes, changes to, decrease into 107 degrees 28 minutes. From 109 degrees 28 minutes to 107 degrees 28 minutes, it is reduced because of repulsions. Here, repulsions are there between lone pairs of electrons and bond pairs of electrons. Repulsions are there between lone pair and bond pair of electrons. Got it, my dear students? Is it clear? Right. We'll go next one. Another example. H2O molecule, my dear students. H2O molecule, H2O, water molecule. Here, what is the central atom? Oxygen. And oxygen having how many valence electrons? 6 valence electrons. You have to represent like this: 1, 2, 3, 4, 5, 6. Then how many bonded atoms? Hydrogen 2 are there. Each one can contribute one electron. Now around the central atom, oxygen, how many electron pairs? 1, 2, 3, 4. That is total number of electron pairs around the central atom is 4. And among that, this pair is involved in bond formation. This pair is also involved in bond formation. That's why how many bond pairs of electrons are there? There is 2. And these 2 electron pairs, that is this pair and this pair, not involved in bond formation. These are called lone pairs of electrons. It is a one lone pair, it is a another lone pair, and this is a bond pair 2 are there. Okay, so that's why here, how many lone pairs of electrons are there? Number of lone pairs of electrons, my dear students. This number of lone pairs of electrons is 1. Okay, so totally bond pairs and lone pairs of electrons, how many are there? 2 are there. So 2 plus 2 will get total number of electron pairs. So 2 bond pairs plus 2 lone pairs will get total number of electron pairs. Right. So here number of lone pairs increases. So that's why here repulsions are take place between lone pair of electrons and also lone pair bond pair of electrons. Right. So repulsions are take place repulsions occurs between lone pair. So repulsions are happening between lone pair of electrons and also lone pair of electrons. So that means here the strength of repulsions is more. The magnitude of repulsions is more. Right? Repulsion strength is more. Repulsion strength is more. Repulsion strength is more. As repulsion strength is more, then what happens? That it deviates the regular geometry and deviates or reduces the bond angle much more. Right? So that here total number of electron pairs 4. 4 means arrangement, that is the geometry of the molecule is a tetrahedral batch. The shape of the molecule is decided by only bond pairs. How many bond pairs? 2. These 2 are arranged in the form of a bend-shaped or angular molecule. What is angular molecule? Or we can say as it is V-shaped molecule. Right? Bend-shaped, angular or V-shaped molecule. There is the shape of the water molecule. And the bond angle is reduces. The tetrahedral angle from 110 degrees 20 minutes to decreases to 104 degrees 30 minutes or 104.5 degrees. Got it, my dear students? 104.5 degrees. Right? It is so much reduced from 109 degrees 20 minutes to 104 degrees 30 minutes. It is so much reduced. Why? Because here the strength of repulsions is more. Here the repulsions are taking place between lone pair. You know, lone pairs are not involved in bond form. These are considered as bachelors. Right? And bond pairs these are already involved in bond formation because they are involved in marriage bond. So that's why among them repulsions are very less, are negligible. Right? So students, between the bond pair also repulsions are there, but very negligible. How can you decide how much that is there? The bond between the bond pairs and bond pairs, the repulsion strength is there, but very less, negligible. How much that is? How can you decide? That is, the repulsions between the bond pairs and bond pairs of electrons is decided by the electron negativity difference between the central atom and bonded atom. Between the bond pairs and bond pairs of also the repulsions is there, but that is very less. That is decided by what? Electron negativity difference between what? Central atom and bonded atom. Electron negativity difference. That is, the central atom is here oxygen and bonded atom is hydrogen. The electron negativity of oxygen is 3.5 and the hydrogen is 2.1. The difference between these two increases automatically. The bond angle also reduces. Got my point? That means here between the bond pair, the repulsions is decided by central atom and bonded atom. Electron negativity difference between these two. Electron negativity difference. Got my point, my dear students? Right. So that means lone pairs between the lone pair repulsions are why? Because they are bachelors, they are not involved in bond formation. That's why in the bachelors repulsions are more, right? The same thing. What are the things that is happening in human society? The same thing is happening in chemical society. The way of understanding, approaching the mind is very important. Then the subject is very made easy. Right? Got my point? Okay. So all of you, my dear students, thanks for watching my video. Okay. Then please subscribe and like it, and it is very motivate me. Okay, so then also in the next class, this is the first part. Some more examples are there, and that part is very important. From that part, different types of deviations are there, and different examples are there, and some tricks are also explained in that second part. So must you have to watch it. This is the first part, my dear students. It is a part 1. This here I expect about just that is main postulates and some examples. So the more deviations I will do in the next part, second part. Okay. So thanks for watching my video. Fine.